So students, welcome back to the interfacing session of DC motors with 8051. Yesterday we have seen direction control of DC motor with 8051, wherein we have explained that because 8051 pins are not sufficient to drive the DC motor directly, so we were using L293D motor driver IC in between DC motor and 8051 microcontroller, so that its current capability is increasing to 600 milliampere and it is efficiently driving the motors, which if this would not have been there, then we would have used transistors. But because now we have IC readily available for this driving purpose, we use L293D motor driver IC. So yesterday we were discussing that how the speed control of DC motor can be done. So we were talking about PWM waveform, pulse width modulated waveform, wherein your T remains same and on time and off time is changing. So when you have on time more and off time less, the motor gets more positive supply for longer time, longer duration, so it moves faster. And when you give less a positive supply for less duration and put it off for more duration, then you get a slower speed. So if you want to run the motor in faster speed, then you have to apply the large on time period compared to off time period. And if you want to slow down the DC motor, then you have to apply the short on time duration and long off time duration. So we were talking about the duty cycle of the PWM waveform. If your duty cycle is more, that is on time is more compared to off time, then the motor moves in faster speed. And if your duty cycle is less, that is on time is less compared to off time, then the motor moves with slower speed. So how to implement this with the help of microcontroller programming? This is our interfacing diagram, which we have not changed. For direction control of DC motor also we have used the same configuration, wherein we were using port 1, two pins of port 1, that is port 1.0 and port 1.1. So port 1.0 is given to input 1 of L293D and port 1.1 is given to input 2 of L293D. And because we are using one driver section of this L293D, the corresponding enable pin is given plus 5 volts supply. Unless until we give this enable activated, it will not, this input signals will not get activated and will not get passed on to the output pins. Now the corresponding output 1 and corresponding output 2 pins are given to the two polarities of DC motor. Let's say we have considered yesterday also, we were talking about that it is not necessary that we should use only the immediate pins for this very purpose, but because it makes program easier, we have tried using the successive pins, that is port 1.0 and port 1.1. So now what is our job? Our job is to apply these type of waveforms. So we will be giving the on time period more compared to off time period, and we will continue this for certain cycles. After these cycles, what we are doing, we are giving the waveforms where on time is less and off time is more, and we will be continuing this for some period, for some counts, for some cycles. So for particular duration it will move in faster direction, and for particular duration it will move in slower direction. So what we are doing, we are taking R7 register. In R7 register we are taking any count FF. Let's say maximum count which we can take in R7 register is only FF. So maximum count, let's say here we are considering that we are taking the maximum count. So that means it indicates that for FF times or for 255 decimal counts, the cycles, 255 decimal cycles we are applying for faster rotation, and the same count we will be using for slower direction. So for 255 cycles the motor will move in faster direction, and for 255 cycles the motor will move in slower speed. Then because we are using port 1, so again yesterday also we have seen that why we are putting FE because when we take the FE stands for all pins are 1 1 1 and only port 1.1 is 1 and port 1.0 is 0. So this becomes FE. It indicates that we are giving 0 to this particular pin and 1 to this particular pin, so that motor will move in one direction. So here we have applied and motor has started moving in one direction. Now what we are doing, we have written one program, delay program. Any delay which you want to put over here, this can be any delay. And what we are doing, we are taking calling it for 3 times: a call delay, a call delay, a call delay. Why we have done this? Let's say suppose if we divide this into 4 parts, we call this as delay 1, and this can be then subsequently delay 2, delay 3, delay 4. So we are writing the program for this particular delay period. Now because of our on time we have taken 75% duty cycle. 75% duty cycle means 3/4 period is on time and 1/4 period is off time. So by writing the delay program for 1/4 delay timing and calling it for 3 times, you are getting 75% on time. So delay program is written for 1/4 of whatever T you are requiring. So you are calling this for 3 times. So total delay which you are getting is 3/4 of T. Now what we are doing? We are putting FC. Why FC? FC stands for 1 1 1 1 1 again 1, and this becomes 0 0. So this becomes FC. So when you are not giving any supply to these 2 pins, both the pins are made 0. Both the pins are made 0. So when you are not giving any supply to motor, the motor stops. So it indicates that this much portion of the program is indicating that you are giving 75% on time to this motor, and for 1/4 time you are putting it off. Then what you are doing? You are calling the delay which you have written for 1/4 time. So this for this particular period the motor is remaining off. For this particular period the motor is getting the supply 1 0. For this particular period motor is off because it is getting 0 0 and on both the terminals. Then you are decrementing R7 by 1 first and checking it for 0, and because R7 is containing FF, so it is not 0. Again where it is going to the F loop location. What is F loop location stands for? F loop location is giving you that again put FE on port 1 because you have to repeat this cycle for FF times. That means you have to repeat this procedure for 255 decimal times, so that for 255 cycles the motor will move in faster direction. So once this is over, once R7 is going to 0, then what you are doing, that means your faster period is over. Now you have to slow down the motor. To slow down the motor, what you are doing, again you have to, because your R7 has already gone to 0 0, so you have to again put FF to R7, and then you are again putting FE in port 1. That means you are giving the supply like this 0 and 1, so that you are starting the movement of the motor, the rotation of the motor in the same direction. Then you are calling the delay only for once. Why only for once? Because your on time is now 1/4 of your T and your off time is 3/4 of the T. So for only this much of period delay, you are calling delay routine for once, and then again you are putting FC on port 1. That means by putting FC, it is again stopping the motor, because both the terminals are getting 0 0. So when both the terminals are getting 0 0, that means motor is stopped. And for how much period it is stopped? It is stopped for, you are calling delay for 3 times. So that means 3/4 time of this T the motor is stopped. So And for how much time you are continuing this? You are continuing this, you are checking again for R7 whether it is 0 or not. First you are decrementing it by 1 and then you are checking for 0. And for how many times you are repeating this? You are repeating this for FF times, that is 255 decimal times. So faster movement was also for 255 times and your slower movement is also for 255 times. And then because you want continuous faster slower rotation, continuous faster rotation, slow rotation, faster rotation, slow rotation, so you are jumping to again to the startup program, that is DC fast. So this is all about speed control. It is not at all compulsory that because here we have taken the example of 75% duty cycle and 20% duty, 25% duty cycle. But suppose if it is asked to you that your duty cycle should be 70% on time and 20% of 30% of time, then what you will do? You will write here delay 1 for 70% on time and delay 2 for 30% of time. So in this particular case, what you will do for this particular timing period, instead of calling 3 times delay 1, now you will call delay 1 which you have written for 70% on time, and here you will call delay 2 which you have written for 30% of time. Similarly over here you will call delay 2 first because it is written for 30% delay time, 30% on time, and here you will call delay 1 instead of calling this delay 3 times. So because here we were having some relation between delay, that this was 25%, this was 75%, and 75 is 3 times 25%. That's why instead of writing 2 different subroutines, we had written only one subroutine delay and we were calling that for 3-4 times. But if you have different duty cycles, then you should write different delay programs and accordingly you should call over here. So I think this is clear to you. Speed control of DC motor. Next session we will continue with the acceleration of the DC motor. Now we all know what is acceleration. Acceleration means you are slowly increasing the speed. So slowly increasing the speed means first the motor is moving slowly, then subsequently you are increasing the on time of the motor, like this. So previously on time is less, on time is less, slowly you are increasing on time and then you are increasing on time to the largest extent. So when you are gradually increasing the speed, your speed is going to be increased. So here the motor will accelerate. So if you want to, we have seen the direction control of DC motor, we have seen the speed control of DC motor, how to make it faster, how to make it slower, and if we want to go for accelerating the motor, then which type of pulses we should give. We should first start with smaller on time. For few cycles we will give the waveforms of the waves of smaller on time periods, and then slowly gradually we will increase the on time of the pulses, this PWM, and when the on time is large, the motor will move faster. So this is how we can write the program for acceleration. So here you have to gradually give this type of waveforms so that your program will change for acceleration. Now before giving this type of pulses, you have to first apply the pulse of 50 milliseconds. So we were talking about acceleration of DC motor. So before applying, first we are applying the pulses of lower on time for particular duration, then pulse little higher on time, then little higher on time. But before giving this, you have to first apply the pulse of 50 milliseconds to this particular phase motor because it removes the initial inertia. To remove the initial inertia before applying the pulses directly, you have to first apply the pulse of 50 milliseconds, and then after that you will start giving the pulses with lower on time. Subsequently you will go on increasing the on time, and again you will increase the on time to the larger extent, so that the motor will accelerate gradually. So I think with this particular programming, direction control and speed control of DC motor, you will be able to write the program for accelerating the DC motor. So this is your one of the assignments for which you will write the program for acceleration of DC motor, and you will submit me through my at my email ID. You all have my email ID, but still I will make it clear to you. You have to submit me the assignment for accelerating the DC motor. You will submit me the assignment in PDF format at my email ID, and next class whenever we will take, I have given my timetable as Thursday, Friday, Saturday 11:30 to 12:20 p.m. For online sessions of my class. During this period we will discuss about the previous assignments also, and we will discuss about your queries also. So by that time you go through my previous videos, previous notes. Again I will be circulating the notes on WhatsApp, so be activated on WhatsApp. You have to give me attendance on your WhatsApp, on our WhatsApp group, on Thursday 11:30 to 12:20 p.m. So goodbye then, stay at home, stay safe.